Let's take a look at problem number 3. Problem number 1 we have already solved. Just to take a quick look, we listed the knowns and the unknowns. We wrote down the equation and then solved it symbolically for the density that we're trying to solve for problem number 1. We substituted the known values into the equation and then solved to get the answer. We also noticed that 1 milliliter is equal to 1 centimeter cubed, so that means my final answer of 3.51 grams per centimeter cubed matches, by the way, the answer that's actually given in the problem. Let's take a look at question number 3. Question number 3 will require a little bit more work with units, and I wanted to make sure that everybody has that skill to do it. So just like before, we have values that are given to us. We're told that the density is 2.33 grams per milliliter. We are given a 0.775 grams as a value in the problem. And we know that it's asking for volume, so V is the question mark. So that means the 0.775 grams is mass. Step 2, mass is equal to density times volume. And now from that I want to solve just for V. So I'm going to divide both sides by density this time. Density and density cancel. So we have volume is equal to mass divided by density. And so far, this problem is working out the exact same way as problem number 1 did. This is where things are going to deviate slightly. I am going to write this same equation slightly differently, where I do m over 1 and 1 over d. One of the things that I've noticed over the years is that students have a difficult time trying to turn 2.33 grams per milliliter and how to put that in the equation when you are dividing by it. When you do that, you're just taking the reciprocal, and let me show you what that looks like and what mistakes people make. The mistakes that people make is, so we have a density of 2.33 grams per milliliter, and if you want to take 1 over density, a lot of people would just say, well, 1 over 2.33 grams per milliliter. The problem with doing that is when that happens, you now have this fraction buried in the bottom of the fraction, and then nobody knows really what's going on there, and it's difficult for people to figure out. We're not going to write it this way. It's really close, but let's figure out what I'm going to do instead. If I want to turn this into the reciprocal of 1 over d, I'm going to write it instead as 2.33 grams on the bottom and 1 milliliter on top. So all I did is I took this fraction and I flipped it over. By flipping it over, I now have my units looking like this. So with that, let's see how that's going to affect this problem overall. We have volume is equal to the mass, and the mass will be easy to write out, 0.775 grams divided by 1. Then I'm going to divide by density. And again, when I divide by density, I'm going to take this value over here. I'm going to put milliliters up on top and the 2.33 grams on the bottom. The grams will cancel. Once grams cancel, you'll notice I'm left with milliliters, and that's a unit for volume, which is exactly what we are looking for. That said, our answer will be, when you plug this in the calculator, because you're going to take the 0.775, and then you're going to divide by 2.33, get an answer of 0.333 milliliters, which we already said is the same thing as a centimeter cubed or a cubic centimeter. So just a quick recap of that particular problem from beginning to end. We wrote down the knowns and the unknowns with the units. We took the equation just like we did before and solved it symbolically for what we're looking for, but this is where we made a slight deviation. Instead of just plugging the values directly in, I wrote the density as the reciprocal so I could get these units of grams to cancel, and then milliliters would be by itself. And again, a milliliter and a centimeter cubed is the same thing, so technically if we want to put milliliters here, but then milliliter and centimeters cubed for the answer matches.